As the nuclei in a radioactive source decay, the activity of a source will decrease. Remember that in a sample of unstable nuclei like this, each nucleus could randomly decay at any moment. We then call the activity the rate at which decays occur. But how would activity change? Well, let's suppose that over 1 hour, this sample has a high activity, and so half of the nuclei decay. But this means there are fewer nuclei left that can decay. Specifically, only half as many as we started with. These nuclei would all have the same chance of decaying as before. So we'd expect only half of them to decay in the next hour. In other words, the activity has now halved. But how can we describe the time it took for this to happen? Well, the half-life of a radioactive isotope is the time it will take the activity of a source of the isotope to halve. Remember that we can also use the half-life to describe the time it takes the number of undecayed nuclei to halve. This is because activity is proportional to this number. But you won't need to know about this at GCSE. So in this case, since the activity of the sample will halve every hour, the half-life of this isotope would be 1 hour. For your exams, make sure you can explain what half-life is, both in terms of activity and the number of remaining nuclei. So with this new definition in mind, how could we measure the half-life of a sample? We can calculate the half-life of a source by measuring the count rate from it over a period of time. Remember that we measure activity using a Geiger Müller tube, which we point at a radioactive source. The device will then click every time it detects a radioactive decay in the source, and the rate of these clicks will be the count rate. The higher the count rate, the higher the activity from the source. Though we should be aware that we're only detecting the radiation directed towards the tube, not all of it. But how do we determine the half-life from this? Well, to start, we should measure the count rate over even time intervals. For example, measuring the count rate every minute, and then making a note of these measurements. The count rate can then be plotted against time. We'd do so on a graph like this, with count rate on the vertical axis and time on the horizontal axis. If we plot out measurements against the times we took them, we'd get a downward curve like this. This is showing that the count rate decreases over time. In fact, it will decrease in the same way that activity decreases, which is why we can now use this graph to calculate half-life. The half-life is the time it takes the count rate to halve from any value. Let's see how this works with our graph. So we can see that the count rate started at 20, so we'll start working from here. Though we can choose any other easy-to-read point as our starting point. In an exam, you could also be given a specific starting value for this calculation. Here, the count rate first halves from 20 when it's dropped to 10. So let's draw a line from this count rate to the graph and down to the time, which is 1.5 minutes. Remember that the half-life will always be the same. So we can look at the time it takes the count rate to halve again to check that we have the same time interval. This will be when the count rate goes down to 5, which happens at 3 minutes. Then the count rate halves again to 2.5 at 4.5 minutes. So as we can see from these time intervals, the half-life of the sample, the time it will take any count rate to halve, will be 1.5 minutes. For your exams, make sure you're confident calculating half-lives from this type of graph. At GCSE, you won't be expected to calculate half-lives from any other type of data.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!